Good afternoon. This is Costonis speaking. I'm the president and founder of Advanced Concepts in Engineering. I've decided to do this presentation based upon the fact that I've had a lot of reach out from people that were not able to attend our presentations in Florida, looking to learn a little bit more about the ACE Auto Grade and a little bit more about what Advanced Concepts in Engineering does. So with that, allow us to begin. We're here to discuss the footing upon which Advanced Concepts in Engineering is built. We are a company that has risen to the challenge to solve the lack of automation in the aggregate industry and the quality control testing segment of the industry at large. The industry continues to suffer from the number of problems with the time to test and repeatability, human error, so on and so on. What we need to do is we really need to increase that data and reduce that time to test cycle and to define the repeatability in the process, removing human error. It's interesting to talk about where through 2017 we're looking to do about 53.2 gigatons this year. It's further important to note that that's an increase. That's an uptick from about 4.6% growth to about 5.8%. And likely with the incoming administration, that number will probably go even further than the 53.2 gigaton. Further beyond that, it looks like the industry is looking to jump to 66.2 by 2020. As the industry grows, the fact of the matter is, as the demand continues, the quality control level standards are going to be sharpened as well. Virgin aggregates, recycled, hot mix, concrete, ready mix, so on and so forth. It's interesting to say that if one's to sit and review the available data, it's mind-blowing to see that in the U.S. there's an absolute positive minimum of 15 million quality control suites on an annual basis. Looking at that number globally, that number jumps dramatically to about 283.5 million. That's at a number of 44 billion US dollars is spent strictly in quality control on an annual basis. As we go through this presentation today, there's a couple things that we'll talk about, but one thing that I want to just put out there briefly that is not readily available information is what's the failure rate? What's the risk rate? When any company is operating, there's a number of failed tests or sublots or tons, yards, so on that didn't meet the spec or it had to be reworked, retested, redesigned, so on and so forth. Typically, that number, from my exposure, has been in the vicinity of about 4 to 6%, and as high as 9%. 9%, obviously, you've got some real issues. But I've seen it pretty comfortably in about the 4% range. But for the purposes of this conversation, we'll keep that rejection rate at about 2%. When we look at the problem in the industry, the current test methods, I mean, they're antiquated at best. They're incredibly labor intensive. The amount of time it takes to produce a test is mind-boggling. Then you have the reporting side of that house where you have data entry, you have writing numbers down, and so there's a lot of error possibility. So now so let's stop there and think about that for a minute. You've got your test is subject to human error. And then, of course, is the transcription of said data. There's a popular software solution out there that a lot of you use, but when you're using that solution, you're still keying data into that. So that doesn't make a lot of sense to me when we have the technology, the means, the ability to have the device that generates the data automatically populate that data into a proper management situation. The net effect is high cost and inefficiency. When we're in a laboratory, it's our job to be effective and efficient. The present standards, methods, and tools that we use are anything but effective and efficient. And I'm not saying that to be insulting, but the simple fact of the matter is, some of this equipment, is amazingly old. I was talking to a client last week, and she told me that one of their primary gradation pieces of equipment is circa 1986. 1986. We're 2017. So there's got to be some progress in where we're going. So Advanced Concepts in Engineering has developed the solution to the problem, being the ACE AutoGrade Laboratory. This is a fully portable, fully automated, fully self-contained gradation laboratory. This will work with your aggregate, your cement, asphalt, ready mix, so on and so forth. The unit's employed with a touchscreen controlled voice response. We drive by vacuum, and I'll get into that a little bit later on. The unit is 100% repeatable. And let's talk about that for half a second. Well, what's a certified test? Well, a certified test, by definition, is if John, Bob, and Jill are all conducting the test according to the specification as written. That's a certified test. Well, if John, Bob, and Jill are conducting the same test, what's the chances that the three of them are doing the same test exactly the same time every single time they run the test? The chances of that are not very good. So then what we talked about earlier with the transcription probabilities, one of the things the ACE AutoGrade does is it automatically emails your test data and stores it, uploads it to whoever wants it, and including the ACE Advantage. There's two words in front of us now that we could talk about briefly: integration and automation. The dictionary definition of the word integration is, quote, the bringing together or incorporation of parts into a whole, or to make up a combination or act or otherwise producing a whole or larger unit. Our labs and our equipment and our data is not integrated. It doesn't make sense to me or anybody else in this segment of the industry. Why do we have a data generating piece of equipment that doesn't carry that data all the way through? Again, there are some softwares out there that say, well, we can upload from this piece of equipment, but not that piece of equipment, and I don't understand that. There's a tremendous void there. When we were doing our presentation in Florida, there was a gentleman that I won't name at one of the presentations, and he said to me, with a half a smirk on his face, well, we moved the keyboard close to the scale. Okay, I got it, and I appreciate the humor in it, but that's the farthest thing from integration possible. Then we look at automation, being the technique, method, or system of operating or controlling a repeatable process by highly automatic means. And it goes on further from there. One of the things that we have to do, and we know in any industry that we work in, it doesn't matter if it's the aggregate industry or the shoe industry or the coffee industry, automation is a key to success. And if you can tie your process to an automated system that's going to give you that same exact step-by-step process and deliver you the same result no matter how many times you run it, that's what's going to make a successful company. The simple fact of the matter here is that systemic integration and automation are no longer optional. We need to update the process in the quality control sector to a level that exceeds the advancements awarded on the laydown side of the house. Now, I'm honored to say that I know some people on the executive level at Aztec Industries, and I was talking with them about plant production rates. You know, and you recall earlier we said that we're looking at 66 gigaton by 2020. Well, our partners on the side of the house that are on the production side, you know, making the mix or concrete or ready mix, so on and so forth, they've already adjusted their plants to meet those demands. The problem is those of us in the quality control side of the house, we're still lagging. We're the risk factor. Well, the ACE Auto Grade and the other products as designed and put out by Advanced Concepts and Engineering solve that problem. We solve that problem specifically through what we call the Total Integration, Total Automation Protocol. This is an interesting process, an interesting guideline, if you will, where we've tried to marry a number of events, for lack of a better term, and happenings, you know, in the way that we design our equipment and the way that the equipment functions. The Total Integration, Total Automation Protocol, by definition, is a protocol whereby the combination of a series of events conducted by a collection of activities are integrated by means of data-generating processes executed automatically by software-controlled devices without user interpretation, thereby ensuring the accuracy of the process, the execution, the results, and the data distribution. This is an interesting protocol if you stop and you think about it. Well, what we've done is in any laboratory, you've got multiple things happening at the same time, multiple processes underway, multiple goals at the same time. So what we've done is we've married them all together and we put them into an operating envelope, if you will, of total automation integration. The ACE Auto Grade does this very easily through a lot of its many features and functions. You know, the internal vacuum drying, you know, we'll get into that momentarily. You know, we've got a repeatable process, 100% repeatable process. You can't knock 100% repeatable. All of your gradation test results is automatically calculated for you and uneditable. It's important to know that it's uneditable. The DOT likes the fact that the data is certified. Typically, we see overall a 48% faster drying time and time to test. And all of your data is automatically reported without any type of interaction from the user. Further on is the fact that every time the system is done, it runs through a self-cleaning process, so on and so forth. To make all of those things happen, we deal with an amazing array of information on the inside. The ACE Auto Grade is comprised of a proprietary blend of equipment that you see in front of you. And again, everything in your gradation lab is contained within this unit. You've got your zeolite, you've got your pressure, temperature, moisture, vacuum pump, your water system and filtration is on board. Further on board, we have a fabulous scale system. And this is a little video that I like to share with people to give you an idea of the diligence and the engineering excellence that has gone into this machine.
3 OSB 225-pound sensors with a 50-pound weight on top. What I'm going to show is when I put a 0.1 gram sensor, or 0.1 gram weight on it, this will take the reading of that weight. So currently it's reading 0 grams because I just heard it. You just put this tiny little thing onto this, and then voila, 0.1 grams.
So now you can see the level of excellence that we put into this thing. You know, typically the unit's capacity is dictated by the number of sieves and size of the material that we're using. When we're doing some testing, some of the differences and the importances, you know, is we need to talk about. This graph you see before you solves a lot of the problem. When we're doing our gradations and our mixed designs, y equals mx plus b. So what does that mean? That's the plot. But if you look down on the picture, you're seeing where your standard sieves are your blue stars. Well, what about the not so standard sieves that are the red triangles, which is you'll see here. This is an untested one. This is untested. This is untested. So how many times have you heard stories of, well, it passed in the lab, but it failed on the road, or something like that? The problem you have is you're neglecting the fact that y equals mx plus b, and if you have a passing test looking here, and then you have a passing test over here, but you failed here, guess what? Your gradation failed. Just because it didn't fail in your lab or it didn't fail on the sieves that you tested doesn't mean that it didn't fail. That's something that a lot of people need to pay attention to. As we go on the process, one of the things that we did, we tried to make it important to protect the sample. As you've heard me say several times through this process, that we dry by vacuum. In science, we know a basic theory. We know heat destroys and cold preserves. Drying by vacuum lowers the temperature of the sample that we're being tested. And one of the things that another sub-challenge, if you will, that Advanced Concepts in Engineering has taken on is the challenge to protect the sample or remove sample degradation. By drying by vacuum, that process has been studied many times. For example, Mr. Pokel did a study at the University of Oklahoma for Dr. Cross, where he studied a piece of equipment that's found in some laboratories that dries by vacuum. And his summary statement is, the specimen remains at room temperature, which helps to retain the characteristics that can be altered due to prolonged exposure to heat in ovens. The simple fact of the matter is that there's a fact that people in this industry seem to negate or reject or just completely skip over, and that's microscopic thermomechanical failure. By generating heat in an aggregate, you're creating thermal failure, be it catastrophic or microscopic. There's a thermomechanical failure element that's not being discussed or analyzed and or protected in the industry. By drying by vacuum, we eliminate that possibility in and of its entirety. ASTM and AASHTO both have acknowledged vacuum drying. For example, speaking specifically of ASTM, citing the 6752, 6752 M11, and the 7227. They clearly indicate that vacuum drying is permitted use for drying loose aggregates, mixtures, samples, cement, ready mix, etc. Solid specimens. As we talk about the advantages of the ACE autograde, one of the things I want to talk about is how many times do you handle a sample? If you are doing a 19 millimeter minus mix and you're using a relatively common array of sieves, you stop and think, how many times have you handled a live sample? If you look at this image in front of you, it's a rather gross depiction of what you're doing and how many times you're introducing a possibility of throwing your test. One of the things that's important to notice about the using the ACE autograde is you never handle a live sample. I'll repeat that. You never handle a live sample. Your sample is not weighed until you load it in the machine. So therefore your sample is protected in terms of its quantity data. Looking at this in front of you, you go from the scale to the heat to the scale to the sieve stack, and then you break down each individual sieve back to the scale. So doing that 19 millimeter minus, you're handling the sample a mind-boggling 14 times in this example. Or in the ACE auto grade, you will handle a live sample how many times? Never. You load the sample. Once the sample is loaded, it's weighed, then it's live. The next time you touch the sample is when the sample is being injected and the test is completed. That's a risk factor. Okay, I do want to take a half a second to talk a little bit more about risk. Speaking specifically in hot mix, for example, if you're looking at the time to test issues and that we discussed earlier, let's talk about a hot mix operation that's doing some 300 ton an hour production. Relatively slow, but we're doing 300 ton. The crusher's running a gross production exceeding 2,000 ton an hour. If we take our 300 ton an hour production and we take 3 hours to complete a suite of tests, that's 900 tons of material that has been produced in this hot mix example from start to finish of testing suite. That's a considerable risk. Now, let's go back to the second slide that I showed you where we talked about the production levels. And then let me remind you about the plants that are being produced. Upwards of 600 or 700 ton an hour is what they're capable of now. If you're 600 or 700 ton an hour and it takes you 3 hours to run a suite of tests, you're 1,800 to 2,100 tons of material down the line in the hot mix example. That's quite a risk factor. So the ACE auto grade, reduces that factor by about 48%. When you talk about the ACE auto grade, you say, well, how does it perform? Okay, it reduces test, but how does it perform? Well, the interesting thing in a standard gauge R&R, the ACE auto grade shows a 22% overall improvement against a standard gradation method. Again, you talked about the 48% time test savings. A number of different things that the ACE auto grade is capable of doing above and beyond the standard gradation is it has a built-in job mix formula module. And I wanted to point out just a couple points here. If you're doing a 4-blend mix, which most of you are likely doing more than that, but if you're doing a 4-blend mix, and you said to your technician, I need to know every possible passing combination, your technician is going to be mind blown, because when you do a blend of four components, there's 104 plus million possible combinations that can be done. Of those 104 million, some 18,500 mix designs will pass standard quality control points. Well, I'll give you a visual of that here in a few minutes. As we've talked about the machine, some of you have likely said, well, is this thing difficult to take care of? Is it hard to use? Is it, what do we need to do to take care of it? One of the things that we've done is we wanted to ensure the fact that you will have a good, be able to focus on your job, focus on the equipment. So we offer what's called a product maintenance plan. This is an on-site maintenance plan where we come to you 4 times a year. Quarterly, we'll come out and we'll look at your lubricants and your oils and drain your vacuum pump and whatnot. We'll do systems analysis on the machine to make sure everything's properly performing as it should be. Any tool, couplers or Lovejoys or guide systems that might need tightening, tuning, replacing, we'll take care of those as well. Annually, we'll come out and we'll calibrate your scales and your sensors, as well as an overall mechanical systems calibration. The ACE auto grade, it's obvious that we've generated a significant amount of data for you. And we said, well, what are we doing with all of this data that we're generating? Well, we're going to generate this data and we're going to upload it automatically to the ACE Advantage data management system. Now, again, most of you are using an existing program that requires you to sit there and key in the data of the test that you've just done manually. The ACE AutoGrade and the ACE Advantage now has automated the process for you 100%. Your machine will automatically conduct your test for you in a portable format. It will automatically upload the data for you. So there's no more keying in. Pens, pencils, crayons. We don't use those here. All of your data is automatically uploaded. All of your data is fully customizable. It's tracked, recallable, manageable by project, location, client, production facility, date, etc. We can export this in a number of formats. We have automated reporting that we can set up weekly, monthly. We could even do daily and yearly if you wanted as well. You have automated email reports on every test that runs. Your administrators will be able to know if there's a test failure or if there's an electromechanical challenge. One of the things that a lot of people like is if there's an electromechanical challenge within the unit will send a code automatically to home, what we call home, which is us, to say, hey, something's wrong. The data that's generated, there's all kinds of cross comparison tools built into the ACE Advantage. We could cross it against a job, a project, type, data, the technician even. When you're using the machine, there's 3 levels of access that'll protect your data. There's even a guest mode if somebody just wanted to come in and look at whatever was unrestricted data. Your data analysis, we're constantly comparing the tests over a period of time, comparing them on location, on date, technician, so on and so on. Your production trend analysis, test measurement. You've got your typical histograms, your semi-log, Power 45 run charts, calendarized reports, multivariable reports using triggered analysis, your data correlation, custom chart, etc., etc. It's important for me to say to you that most of you are using a product right now where you have to key in your data that will generate similar results for you. The ACE AutoGrade and the ACE Advantage is a hands-off with all that data automatically generated for you. When you're using the ACE AutoGrade, you say, well, what is it going to cost? Everybody, well, that's the end result of what's the cost. The cost comparison run a standard method. If you're running a small operation, and say you're doing 270,000 ton production, and you've got an all-in cost for your technician of about $35 an hour, based on a common DOT testing interval schedule, on your T11, T27, or 117, 136, you're looking at about $194,400 in expenses. Doing those same exact amount of tests using the ACE AutoGrade, beyond the fact that your data is in the upload, you're at $149,000. So you have an efficiency add back of some $45,000. That efficiency add backs, it's like a mixed benefit. You reduce your payroll, increase your test numbers, more tests conducted per time by the same number of technicians, so on and so on and so on. You'll remember earlier we talked about the reject rate or failure rate of 2%. If you have a system that's giving you 100% repeatable process, your reject rate that's insulated based upon a 270,000 ton production facility is some $540,000. I'd like to talk to you a little bit more about it in person, and and I'd be happy to come and meet with you and do a demonstration for you. My contact information is 207-270-3025, or feel free to email me directly at jfcostonis@advconeng.com. Before we go, I want to give you just a quick introduction to the ACE Auto Grade and its usability. You see here before you, this is the home screen of the unit. You can see that it's touchscreen because that's the interface that the user uses. I need to make sure that everything is working in the system.
Please wait. Checking system. Resources.
The system will go through and literally send messages to every piece of equipment in there to make sure that it's working and fully functional and ready for use every single time you start the unit.
Checking load cell communications. Pass. Checking pressure. Sensor communications. Pass. Checking temperature moisture. Sensor communications. Pass. System ready.
So now the system is checked. You see we have a full water tank and we have all green. So let's look at some information that we have here. Let's look at some test data.
Please select the data file to open.
And today is January 4th. So let's look for test number 4. You have the live data as it's testing. This is April 13th, 2015. You have your report data and you monitor. That's a live data thing. And you monitor. You see the green and the white? I want to explain to you the green and the white. So why is some green and some are white? When I go to configure a test, and I'll run the same one that I did in Florida. As the ASTM demonstration.
To use identification data profile.
One of the things that's important is if you're running the same test over and over again, if you're paving Interstate 95 or whatnot, and you want to use the same data over and over again, you can select it, and you see OK to use identification. You say OK, and you'll see these populate by themselves. And you see this is set up for a mixed gradation post burn. This is in an asphalt format. You see these sieves that are some are checked and some are not. The unit's going to test each individual sieve. It'll report on what you select, but it's going to test in this unit 15 sieves. One of the things that I want to show is if the unit, if you don't set everything up correctly, the unit's designed to make sure you cannot make a mistake. So I don't have a type of gradation selected here.
Error. The following information is missing. Gradation type is not selected or sequence file is missing.
So that's just an idea of what the redundancy that's built into the machine to let you know that it's done and ready to go, and make sure that everything is proper. So I'm going to accept my test data.
Gradation information has been accepted.
And we can go ahead and we can run the test.
You have chosen to activate the mix post-burn testing sequence. If this is correct, click OK. If not, click Cancel. Automation notice. The unit you are using is employed with intelligent software operating under the Total Integration Total Automation Protocol. When a test is initiated, a series of actions are programmatically initiated. It is for your safety that doors and test chamber remain closed and that the unit only be operated in the manner of which it was designed. Your continued use of the ACE Auto Grade acknowledges this statement. Safety notice. The engineering department at Advanced Concepts and Engineering has taken considerable effort to ensure your safe operation of the ACE Auto Grade. Under no circumstances should you attempt, at any time, any electromechanical repairs or service on the ACE Auto Grade.
If you have a service issue or question, please contact us 24 hours per day at 207-270-3025. Abort notice. Should the need arise to abort a test, the unit will complete its present task at hand while the abort button is pushed. When a dialog box is on screen, the abort button within the dialog box takes priority. Should you need to stop the process in an emergent nature, use the EMO button to your left and it will immediately shut down the entire system. All data will be lost for test being performed.
So you have your safety introductions and warnings as you're going through the test.
The zeolite heater will now be activated. Should you be required to open the door to the left, take care to be certain not to touch the heater.
That would be the replacement of the flasks and the zeolite you have on the shelves in your laboratory.
The system will now ensure proper operational capacity and calibrate.
What it's doing right now is it's cycling the pressure, it's cycling all of the valves, opening and closing, and turning the pumps on and off to make sure that everything is fully functional and ready to run. It will run a systems check like that every time it runs a test.
The system check is positive and operational.
As it goes forward through the test, it'll generate all of the
Open
data.
the chamber lid. Make certain there are no obstructions in the chamber. Load the first 8 sieves, smallest to largest. Make certain that the arrows on the sieves are facing the user.
Now the elevated repositioning to take the next set of sieves.
Open the chamber lid. Make certain there are no obstructions in the chamber. Load the next 7 sieves, smallest to largest. Make certain that the arrows on the sieves are facing the user. The system will now record tear weights.
Now what's happened is now you put 15 empty sieves in the unit. And if you see over here on the far left column, the sieve gross column over here, these numbers are slowly going to start to populate. And you'll see a cumulative number here as your first. And then what it'll do is it'll tear out and get each individual weight of the sieves empty. And I'm not going to run a full length test here because I don't want to. I've already kept you in front of the screen for 37 minutes if you're still with me. So, but I want you to see how this works. So now you see you've got a cumulative growing number here of all of your sieves. And then you'll get a tiered weight of each individual.
Please unlock and open the chamber lid. Press OK when complete. Pour your sample in a circular pattern about the center of the top sieve, leaving no less than 2 inches between the sample and the center hub of the sieve. Close and lock the chamber lid. Press OK when ready. The system will now record dry weights.
So now it will go through and it'll weigh everything again, individually, one at a time. Oh, excuse me, over here, because this is a post-burn gradation. So you'll see these numbers are slightly different. And this is showing the weight of the material that you put on the sieves. And then what's going to happen is your dry tear, it's going to take your dry gross, deduct from your sieve tear, and give you your material only. But they're not representative of your final gradation.
The individual sieve weights are not representative of your final gradation. The ACE Auto Grade will no perform the gradation on your sample.
Now I want to show, as it's doing this, I want to show an abort.
Operator aborted the test.
So now what it's done is it's stopped, and what it's doing right now is it rehomes everything. But I want to go through and I want to show you a little bit more function about the machine because I don't want to take up a whole lot of your time here. Let's do a mix design. Again, we're in an asphalt format, so we're going to do a mix design. And when you see this here, please select control points. You have a couple preloaded control points, and you can edit them all, or you can put in your own. So let's go with a 12.5, and I want to use that one. And you see your control points are populated. Earlier we spoke about y equals mx plus b. You'll see these ones that are not checked. That's your y equals mx plus b. Okay, solving that problem. And if you wanted to see your control points, then you do plot your control points. If you want your restricted zone, some people use it, some don't. So there's nothing to plot because there's nothing there. One of the things I do want to show you is I want to edit this. I want to show you that, let's see, this is on the wrong screen, so it's not going to let me do that.
Operator canceled control point edit.
It won't let you make a mistake. If you crisscross your control points, it won't let you do that. You want to plot your maximum density or not. So now we want to make a job mix file, and you can choose to make a mix design under any format that you like. And I'll bring that screen over here. And we're going to call this, we're going to say, okay, we're doing a 12.5.
Please select the control point type to open.
That's a standard.
Please select file to open.
12.5. So this is your median target here. Okay, and what I want to do is I'm going to purposely do some things here for the authentication purposes of what I'm talking about here. Let's move this. These are just slides that move up and down. So if you want to design your own mix based upon your median that's generated for you, you can just slide these sliders up and down to wherever you want them, and it won't let you go out of the control points. So that's the target that we're going to choose. So we're going to check it to make sure that it's okay.
Plot values have been accepted.
And obviously it's okay. So now we're going to save it, and we're going to call this January 4 video demo. And we're done. So now we're going to go to the job mix predictor. And the job mix predictor, if I can get this screen, it's not going to let me put that screen on there. It won't let me move one screen to the next because it wants to all operate on one screen. The job mix predictor will take those four blends and put them together for you. When you look at the tech mode or the system settings, voice, you can shut the voice off, you can turn it on. System settings, if I wanted to say I want to add a user and we want to call this person user 1, and their password is going to be 123, and they're going to be a guest, and their email is info@advconing.com. Accept. I want to enable email and give them test reports and error reports. But I want to make sure that their email works, so I want to send them a test email.
Test message has been sent.
And if I go and I look at my email now, I have an email message from the ACE AutoGrade. So now I want to add user 1. And then if I go up here, there's user 1. There's a lot more to talk about. I wanted to keep this under 45 minutes with you. So I hope that this has been educational and that there's some things that we can do here. And I look forward to talking to you. So don't hesitate at all to reach out to me for any reason at all. And we'll look forward to doing some business together. Thank you very much for your time, and I do appreciate it.